Everything cooperate with me. Okay. Man, I should have cleaned this board. Too bad. Can you tell me what is the volume? Ooh. What's the volume of this?
Length times width times height.
Yeah. What is length times width?
Area.
Area. So what's the volume? Area times height. Area of the base times the height, right? Do I just tell you those two things?
Is it 2 times 5 at the bottom?
It doesn't matter. I really want you to understand. It does not matter. I want the volume. If I want the volume, do I care about what any of these individually are necessarily? No, I don't. Right? I really want you to get that. It could be 2 and 5. It could be 10 and 1. It could be 20 and 1/2. It could be square root of 10 and square root of 10. Just anything that multiplies by 10. And it doesn't matter. It doesn't. I really want you to understand. Does everybody understand what I've written here? Isn't that this? So I kind of already did the first step. I multiplied length and width, and I got whatever you had on your quiz, right, for the area. So all you got to do is multiply by the height. But as someone pointed out, I forget who it was. Was it John?
Yeah.
I gave you different units, and of course that doesn't go. So that's all you had to do. Yeah, you basically summarized exactly what the problem is.
Well, that's irritating. I thought it was more than that.
We had a problem. Do you guys remember the problem about I think it was the volcanic ash falling? It's exactly this, just kind of backwards in a way. But that's all right if you don't see that, but it's the same idea. And again, so I have to multiply length times width times height. If somebody says, oh yeah, length times width is 10 or 12. Okay, they've already done some of the work for me. I just got to multiply by the height now and make sure the units are the same. Yeah. All right. All right. Anything else from the quiz or from homework?
It looks like I did number 5 on the quiz. I just completely botched it. Could you walk me through that one so I make sure I know how to do it?
All right, let me see. Here we go. Let's see what that was.
Oh, really? Wait, I thought I got that one right. Hold up.
Yeah, that was just unit price. You just divide cost by, in this case, ounces, right, to see which one is better. Of course, in that case, the one that comes out lower is better. That would be a lower cost per ounce, right? So all number 5 was a unit price question, just to figure out which one costs less per ounce, right? Most of the time, the larger one is the better buy, but sometimes they get you, right? Does that make sense?
Yeah, I think I might have just made a calculation error or something, because I'm pretty sure, looking at it now, I'm pretty sure I understand it. I just saw that I got it wrong and was just like, hey, let's do number 5.
All right. All right. Well, let me know if it's not clear what went wrong. Yeah.
Oh, sorry. So I would divide 16 by 365 and, or no, 16 by 495 and 12 by 365, right? No?
No. I mean, you could, as long as you understand how to interpret what you're doing, but it's much better to divide cost by units, right? Cost by, in this case, cost by weight. Because then it's simple. If one is costs 50 cents per ounce and the other one costs 40 cents per ounce, then the one that costs 40 cents per ounce is the better buy.
Okay.
Cool. And of course, I didn't really write this down there, but I'm assuming it's the same shampoo. It's just different sizes. So you can't say, well, the one that's more expensive might work better. No, it's the same shampoo, just different sizes.
Yeah.
Yeah. I remember shopping for my favorite cereal, and I went for the family size cereal, and then I took a second and I was like, wait a minute, that costs more per whatever. So I just bought 2 packs of the lower one. Anyway, that happens all the time. They get you. Anything else, quiz or homework stuff? Okay. All right. If you, I've got the grades, basically we've only had 2 quizzes. That's the only grades we've had so far. The homework, I don't even calculate what that is till the end because you can turn in stuff late, you can turn in corrections, but I do have a range. Like what if you had no homework all the way up to perfect homework, right? So if you're curious, you could always either email me or something after the midterm or maybe after the next quiz. I'll see how I'm feeling. I'm going to add a grade into the Canvas grades. That would be 3 grades. I'm going to add your average, what it would be with no homework, and what it would be with perfect homework. So then you can figure out kind of where you are. Does that make sense? Okay, so we'll see. I don't know if you've noticed, if you look at your grades, I don't let Canvas calculate the grades because Canvas is shit at that. It's really difficult to tell it what I want, and then it makes all the grades wrong, and then I got people upset when they find out later it's not with the right grade and blah, blah. So I'm like, screw you, Canvas. I will do this manually. Okay. All right. Get out of here. If there's no other questions.
Would you mind just briefly going over 6? I think I just went the wrong way with my decimals, just real briefly, if you don't mind.
Yeah, it's a good idea. Only a few people did this, but the old King Henry died Monday drinking chocolate milk. You write that down, and then you just have to count how many places to go. I'm not sure what to do with that. So like, let's see. Yeah. Okay. So if I have kiloliters, hectoliters, this is liters, right? Deca. And then liters, and then and then deciliter. Good job, Jeff. And I want to go from I got like 78 deciliters, and I want to go to hectoliters. 1, 2, 3. 1, 2, 3.078. Done. Next. Right? That's all it is. Why is it so simple? Because metric has the same places in its units as our number system does. So that's beautiful. It's based on 10 instead of being based on 12 inches and 3 feet and king's foot size and bullshit. Yep. Okay. Sorry. I'm feeling a little feisty today, I think. I'm actually feeling a little crappy today, but we'll see how it goes.
Hello, Professor.
What?
I took the long route here. I took the long route to Zoom this morning.
Oh, okay. All right. Did you hit
I'm a
traffic?
little sleep deprived.
I understand.
Yeah, right.
I understand.
Actually, no, this has been my life as of late. But it's been exciting reading all the papers and all that. Would you mind repeating that just really quick? We're converting hectoliters to deciliters?
Other way around. So, yeah. So if I start at deciliters, so I'm there,
Yes.
and I want to go to hectoliters. 1, 2, 3. 1, 2, 3.078. Next. There's nothing more to it. I don't even know how to say that in a different way. That's why we have the King Henry thing. So because if I can write this stuff, and of course it keeps going, but I wrote too big, right? Then it goes centa and milli, right?
Yes.
But that's it. If you can write this down. So if I have 1.9 kiloliters, how many decaliters is that? So I'm here, 1, 2, 1, 2, 190, next. Because every step I take is a step of 10. Times 10, times 10, divided by 10, divided by 10. I think our brain can't process it because we're Americans and we're used to working for our units. We're like, no. Wait, what? You got to look up how many teaspoons and shit. No, you don't. It's just, maybe, no, maybe, no. So, if I have, I don't know, I can do grams. If I have 78 grams, how many hectograms is that? 1, 2, 1, 2.78. I mean, it's, I like the number 78 for some reason.
So where's your grams above the liters?
Yeah, this spot. So again, kilo blank, hecto blank, deca blank, blank. So it could be grams, liters, or meters.
Yes. Okay.
So that's the middle spot is that. So King Henry died Monday, King Henry died laughing, King Henry died giggling. I mean, there's all kinds of silly things, but that middle spot is just telling me what the main thing is. And all the prefixes stay the same. So I'd have kilograms or I'd have kilometers, which is also pronounced kilometers, whatever.
Right. Yeah, I was thinking about that right now. Kilometers. That's good. Thank you.
Sure. Okay. The book makes it sound a lot harder. You guys agree if you've looked at it? It's got all kinds of divided by 10 to the 6th and bullshit. I don't care. The book talked a little bit about like micrometers and stuff like that too, which I'm not going to make you responsible for, but there are obviously smaller units than milli and larger units than kilo, right? Mega, like megaton, gigawatt. All right, anyway, all right. Anything else, guys? Is that good? Anything from the quiz? Quiz graded, take a look. Anything from homework? Okay.
So the homework's going to be due at 8 in the morning now. I
Yeah,
totally missed that. Totally missed that.
I don't understand. So I think this is the same thing I did for this quiz. Didn't I make the homework due? But I was thinking about changing that because here's what I'm going to do for the quiz tomorrow. I was going to, sorry. I was going to make it active after the class, but I'm going to make it due like, Friday afternoon because.
Oh, thank you. Thank you so much.
Yeah, because it makes sense. So I was going to make the homework due. Let's see. I'm pretty sure I did that for the quiz too, didn't I? Make the homework due before the quiz. All right, Jeff, you can
Homework. Yesterday's homework was due at 8 a.m. and I thought I was feeling so proud of myself. I thought I was on it, submitting it before 11:59.
Oh, I see. All right.
It was due at 8 a.m.
Again, guys, I know this is weird to get used to, but I put the due dates in there because we're human. If we see a due date, we're more likely to do it. But if you get it turned in like up to a day after that, it's not going to hurt you that much unless you turn a lot in late. Like I've been trying to tell you, I have to put due dates in there. I want to put due dates that will help you out the most. If I don't put due dates, then we're human. We're not going to do it. How do I know that? Because I had a semester where I put no due dates and everybody died on the first test.
Wow. Well, yeah, it helps. So the quiz will be due Friday at what time? At night?
Yeah, that evening, I don't know, probably 6 or something. How's that sound? But I was going to change the chapter 3 homework due date to be probably, let's make it 11:59 p.m. on Thursday. I don't know if that, it doesn't matter, to be honest. It really doesn't matter. I don't know if you guys, I'm just trying to trick you into doing what's best for yourself, is really all that is. There we go. There we go. And this one, do it live.
I was reading I printed out the worksheets that you sent us yesterday.
Sure.
And your notes also, which is very helpful, because that's what, that's the first time I learned it. So that's first impression. So it helps a lot to have that.
Sure.
Anyway, I noticed on page 2, I don't know if I don't know if I noticed a mistake there where it says we moved 3 places to the left.
Yeah, there might be. Let's see. Wait a minute.
Page 2. I can show you after class to not take up the time.
Well, this is important. Let's see. There might be something. So just remind everybody what she's talking about. If you go to modules, there's one called Math for Science, which is really what the little pamphlet is for these workshops that I used to do. So you're saying where now?
Page 2.
Page 2.
This is really fun. I had one of those moments where it's, when you have those moments and you're saying, oh, this is so good, or this is so nice. It was actually, fun. It's nice when you have all the time to do that,
Sure.
Yeah.
Where are we at though? Where's the mistake?
Page 2, way down where it says, okay, see the bold where it says 1.4 exercise problems right there. Okay. That sentence right above it where it says we moved 3 places to the left. And look at the numbers.
Oh yeah. So it should be right. Yeah. I told you guys I have trouble with left and right. So I should have written those in terms of big and small, but it did this a million years ago. So I was trying to keep up with what most teachers were teaching. So you're right. Yeah, that should be to the right. Yeah.
Okay, great. Thank you.
I would much rather say it was a small number, and that's why it's negative, the exponent. But yeah, okay. Thank you. Okay. Have you ever had a teacher that's like, I am perfect, everything I say is perfect? I had several of those teachers.
You shouldn't be teachers.
Exactly. When they make a mistake, it just becomes disgusting for them to try to weasel around. I'm like, I'm a freaking human. You call me out if I make a mistake.
Definitely, of course. Yeah.
I like to say even
That's a good
Stephen
teacher.
Curry doesn't make every shot he takes. If that means anything to anyone. Steph Curry, air ball. It happens. It happens. Not very often. Anything else, guys? I think that's pretty good. Okay. Just to kind of close the door on chapter 3. The last thing we did is really the main reason why I posted that thing we were just looking at, the pamphlet, the Math for Science thing, pamphlet, the booklet, the whatever the hell you want to call it. Because it's got the explanation of Sig Diggs. That's just the same way I explain them. The book really, really does make it sound much more difficult than it is. they have like 5 things, and they talk about the 0 means something in this case, and it doesn't mean anything. And oh my God, it's just, so the 2 rules we talked about yesterday, the 2 rules accomplishes all the stuff that all the crap the book says about the 0 means. It does the exact same thing, just so much cleaner. All right, so let's do a couple examples of that just to get caught up. Oh, scheisse. Let's see. Oh, I got like, look at this. Look at all this. Holy shit. And I'm always using black. All right. But I don't think it really shows up different for you guys anyway. Different colors, but oh well. All right, where are you? All right. So let's see. What we did yesterday, we talked about this thing called sig digs, significant digits, right? Can somebody just tell me what the purpose of sig digs is?
To read big numbers in easy way, make it easy to read and to work with big numbers.
No, that is, what is that one? That's not significant digits.
That's
Scientific.
I can't remember the other word.
Scientific notation.
Do you know how specific the rounding is?
No, it actually doesn't say anything about rounding.
It specifies brackets, doesn't it?
Brackets. What do you mean brackets?
So like, if, as you said, like team A was 0.03 and team B was 0.030 or 0.031, then team B was more specific with the, like, from 29.1.
Yeah, okay.
Yeah.
I got you. So that's pretty much it, but it's really about certainty. How certain were they with the measurements they took? Right? So it's not rounding really, because remember the 2 examples we had? Aw, poor little dude. Oh, he's kind of dying. Was this versus this, and it's not really a rounding thing at all. In fact, math would look at that and say, what's your problem? What are you doing? What the shit is that? You know, math would go, what the hell? But science says, oh, these guys have more, well, no, not necessarily. They don't have more balls. They just are more certain about what they've measured, right? Okay. And then an even better everyday experience is if somebody said, I think about 10,000 people are showing up. If somebody said about 10,000 people showing up versus if somebody said about 11,900 people are going to show up, which one is obviously more certain about what they're saying?
The second one.
Yeah. So the sig digs, how many sig digs? Who remembers? How many sig digs does this have?
1.
1. No decimal. So you start at the first non-zero and you end at the, so that's 1. So how many sig digs does this have?
3.
1, 2, 3. So the one that's got a higher number of sig digs is representing more certainty.
And if you were to add those together, the answer that you'd come out with would have 1 sig dig.
No. Careful. I appreciate the attempt. When you multiply or divide sig digs rules, right? The one that you're least certain about. So if I multiply these 2, the answer would have 1 sig dig. If I add, subtract, they have the same number of decimal places. So the funny thing is, if I added these 2, how many decimal places does this one have?
3.
No.
No.
0.
None. Right? Does it have any decimal places? Nope.
No.
Does this one have any decimal places? Does this one have any
No.
decimal places? No. So my answer would have no decimal places. So if I add them together, that would be the answer. I'm like double checking. Did I add right? All right. You never know. You never know. So again, I know this is a little bit wonky, and that booklet that I posted does go step by step through this idea. When you multiply, the answer has to have the same sig digs as the least number of sig digs. So it's got to be equal to the least, the weakest piece. Same thing with adding, subtracting, but it's based on decimals, because when you line them up, don't you line them up based on where the decimal is? So that's what rules the day when you add and subtract.
Excuse me, can you repeat that again? When you multiply, the answer has to have the least,
Yes.
has
So
to have
this
the
is what I get
least.
if I add, what do you get when you multiply those two? 10,000 times 11,900. The quick way to do that is to go 11,900 and then tens, hundreds, thousands, 10,000s. All right, this is a little weird. Are you guys with me? You can double check me. You never know. If I multiply those two numbers, I get this. Does that have the right number of sig digs? How many sig digs will the multiplication have to have? What's the weakest piece?
The 1.
The 1. So this has to have 1 sig dig. So it has to have, this would be 1 sig dig. So now I have to round it to this place. So that would be 1 0 0 0 0 0 0 0 0.
So it has to have the least digit, the least
The
digits.
least significant digits. Yes, you have to
Great.
round it so it has the least sig digs. Let's do a couple more examples. This was a little bit all over the place. Let me kind of focus. So if I do 490 times 0.5274, how many sig digs does this dude have?
3.
No,
2.
2. When there's no decimal, first non-zero to the last non-zero. That's all you got to remember. If there's no decimal, first non-zero, count to the last non-zero. If there is a decimal, first non-zero all the way to the end. So how many sig digs does this have?
4.
4. I like it. Now, the next step then is just to throw this in the old calculator and write down what you get. And then the last thing we worry about is rounding it to the right place. So somebody help me out. What do you get when you multiply 490 times 0.5274? I would guess 249.
258.426.
That's bad, Jeff. What is it? 258.426.
426.
All right, cool. All right. So it's not the answer yet. Math is cool with that answer. Science says, no, you're communicating too much certainty there. How many sig digs does this number have by itself?
6.
6. Oh, shit, that's way too much. We are pretending like we are really certain. But what was the least certain thing here? Of course, was this dude. How do I make this guy have 2 sig figs? I round 1, 2 to this place. What do you get when you round 258.426 to the tens place? Round it to the tens place.
260.
260. Bam. So is that close to this? Yes. Does that have the weakest sig? Yes, it does too. I really hope that makes, now again, the interesting thing about this class is it's sort of like What does math look like in logic? What does math look like in, we're about to get into politics. What does math look like in science? What does math look like here? That's sort of like what this class does. It says, all right, you know some basics of math, but you haven't seen what math looks like in all these different situations because it's situation dependent. So what science does with math is it tries to use it to communicate more. Math says that's the answer, and science says this is the answer for science. It communicates something. Okay. If I write this in an article, people are like, holy shit, man. You measured good, right? And I'm lying. I'm lying my ass off. This is more better, Jeff. Is that what you're about to say? This is better because it communicates the fact that there was something I wasn't sure about. All right, now, so I really, you got to understand why this exists, which helps you understand the two kind of rules, which helps you understand how to do these problems, right? So it's okay, it's what I hope. So if you really don't buy into why this exists, it's going to make everything a little bit harder. Even if you disagree, you're like, science, you're full of shit. You can still understand why they decided to do this, right? Okay. If you don't like it, you can go try to change science. Go. Okay. So what about, what if I was going to add these two together? This is going to get interesting. What if I add 490 plus, where am I at? 0.4 group jobs? Yeah, there you go, Jeff. Oh, it's going to be interesting day today, guys. Strap in. Either I feel bad or my meds I took are kicking in. Oh, yeah. All right. Thankfully, I didn't accidentally take NyQuil instead of Dayquil. What's going to rule the day here at the end? Here it was Sig Diggs is going to rule at the end. What's going to
The
rule?
decimal place.
Decimal place. So which one of these has the least decimal places?
The one on the left.
This one. How many decimal places does he have?
0.
0. So if you add these together, you get 490.5274. You shouldn't have to put in your copy, right? Round it so it has no decimal places, which means round it to here. What do you get when you round this number to here?
491.
Yes, because the next one's a 5. So that would be the official scientific answer.
You round it to the, I'm sorry, you round it to where?
The least, so it has the same number of decimal places as the one with the least decimal places.
Okay, okay, need to write that down.
And now watch real quick. If I used the same rule as multiplication, this is not an extreme example, but I think you'll get this. If I use the same rule we use for multiplication and division, if I use this, then I would have 2 sig figs, right? I would round it to here. That would still be 490. Does that make sense? 490 plus a half is 490. Does that make sense?
No.
That doesn't make sense on any level, which is just one little thing about why don't I use the same rule we use for multiplication, Jeff? Because it leads to bullshit. That's why. That's always an easy way to throw something out. Does it lead to bullshit? Oh, we should throw it out. Okay. And I know this is new. I think this is new for everybody. I think I asked if anybody had heard of this before. Normally when you take chemistry, they do talk about scientific, not scientific, but significant digits. What do they call them? Significant figures in science. But it sounds like at the most you just don't remember doing that possibly. Anyway, so this is kind of new to everybody. But it's not like crazy hard. It isn't. It really is all about throw it in a calculator and then round it correctly, right? Throw it in a calculator and then round it correctly. You just have to remember, am I multiplying, dividing, or am I adding, subtracting? What's the rule? Okay. Maybe. All right. One last thing I want to say about significant digits, and then we're going to move on. What if, remember that 10,000? Doesn't this officially have one sig dig? Right? Poor little dude. What if you measured the shit out of something? What if you had a crowd and you counted each person, and as you count them, you put paint on their face and they start chasing after you? You put, sort of like when they go by and they put the little marker on your tire when you're parked somewhere. If you don't know what I'm talking about, then I don't know. You haven't fully experienced life. But they put the little chalk mark on your tire. So you put paint on the face paint, and then you count exactly 10,000 people. Is this fair then? Is this fair? No. So how do you get around that? Scientific notation, kids. So how would I write this in scientific notation? You could do it.
10 to the power of 3.
No. 1.
4.
Oh, I see what you did. You got to make it all the way back so there's a single digit, right? Why am I leaving room? Because I'm going to do this. Now, I really want you guys to understand. Are these the same number mathematically? Of course. Multiply by 10 to the 4th. 1, 2, 3, 4. You get 10,000. But how many sig digs does this have now? Why does it have a different number? Because there's a decimal now, right? So how many sig digs?
5.
5. I love it. So that is the way around. The one thing with significant digits that would not be fair is if you actually were certain, exactly certain about something that's a whole number. It wouldn't be honest to do this. Do you see? It wouldn't be honest to add this, because now you're saying you have 6 sig digs. Oh boy. Right? It's not honest to do that. So what do you do instead? Make that in scientific notation so you can show. So if one team had this versus another team had this, now they're both the number 10,000. They are both 10,000, but which one is more sure about it? Which one is more certain?
The
The
second
bottom one.
This one, yeah. Because this has how many sig digs? 3 versus 2. Yeah. So scientific notation gives you the way to be as honest as you can, and it makes it fair to really communicate how many significant digits you've got, which is why in a lot of analysis papers, a lot of journal articles, you see a lot of scientific notation running around. Okay, but if you look at those bad boys, wherever it's necessary. Okay, so that's one little thing. Will this definitely show up? I don't think so. I don't think this necessarily shows up, but I just like to say this because that's the one place it's not fair, but there's a way to make it fair. Okay, now, one last thing, I guess, in chapter 3. It's kind of related to percent change. I'm not sure how much of chapter 3 you guys have done. Well, I know one person's turned in some of chapter 3 homework. There's something called absolute. What do they use? Yeah, okay. Absolute.
Oh, that's what I wanted to ask. Absolute and something.
Well, absolute comes up in a few different, there's something earlier in chapter 3. This is in section 3C. There's one called absolute, what do they call it? No, Jeff. Absolute difference or something like that. Right? There's an absolute difference or absolute increase or something. And that's pretty straightforward. If I had something that cost $7 and I mark it up to $10, what was the absolute change? Maybe that's what they call it, absolute change. How much did it just absolutely change by?
$3.
$3. What would the relative or the percent change be? This is a good review. The absolute change is $3. What would the relative or the percentage change be? Who remembers? It would be the change
30%.
divided. Yeah, sorry. No, careful.
No.
Where did it start at?
7.
7. So it would be 3 out of 7, which is 0.43. I don't know, I'm making
Yes.
Ha 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 ha. Yeah, I got my divided by 7s memorized. Isn't that crazy? I don't really have them memorized, but effectively, anyway, whatever, math boy. All right.
So the absolute change is just like we normally do it.
Yeah, how much did
And
it
then-
change? That's how much did it change?
5 minus 3 is 2.
Yeah. Relative or percentage change is the change compared to something, and it's normally the original amount.
So you take the change and the
Yes.
original amount.
The change compared to the original amount. So, yeah.
Okay. Thank you.
Yeah, because if I double this, won't it go up by 7? No? Okay. All right, we'll stop. So coming up here, I have the same first words here, absolute and relative, but instead of change, it's error. So it's really the same formula. The idea here is I have a measurement and I have a known value. Gather. This happens a lot in physics. We have a theoretical like weight of a proton. It doesn't matter what it is, kids, but we have a theoretical weight of a proton. And then I do an experiment and I measure the weight of the proton. Right? Really, Jeff? Proton? So the absolute error, so if the actual weight of a proton was 11 units, whatever the units are, and I measure, so this is the absolute, and I measure, I'm sorry, this is the measurement, this is the known, you could do it, buddy, all right, and I measure it and I get 12 units. What's the absolute error? How much off was I off by? Same thing like down here.
1.
1 unit. But what was the relative error?
1%.
No. So the relative error would be the error divided by the true value. So I didn't really put these down. So this is the true value, and this is what I measure. All right, everybody stay with me. So instead of there being an original and then a change, there's a known value and a measured value. So what do I always divide by to make it a percentage? I always divide by the true value. It kind of makes sense. I want to compare what I did to what's true. So this would be an error of 1 out of what should be 12, right? That's I'm sorry, 11. You can do it, buddy. The true value, 1 over 11. And that is 9.1% roughly. I think. Is it?
I got 090 repeating.
090909.
Yeah.
So roughly 9.1%.
So to make it a percentage, we divide the
By the true
Error.
value. Yeah. How much
Error
we were
by the-
off by divided by what's true. So really the relative error is what percentage of the truth were you off by? That kind of makes sense. And in this case, it's what percentage of the original did it change by? So these are almost exactly the same idea. They're the same math.
So
And
the,
yeah.
the known value is also the true value.
Yes.
Okay, yeah, because I see 11 here. I have it down, I have error literally next to the number 1 and the true value next to 11, and I see it's the same. Okay, great. Now you explained this in all of the worksheet that you posted, right?
I think this does come up.
Okay, yeah, because it's when I read this and when I read the book and then I read the worksheet, it causes like a little bit of confusion because this is like easy. The way you describe it, it's like super easy where I can understand it.
Sure.
Great, awesome.
Okay. And sometimes the way I explain it sucks to somebody, but then when they read the material, it's like, well, that made sense, Jeff. What's wrong with you? And I'm like, well, I got to give a different. So what I do is I try to be not a walking book.
Yeah.
Give a different interpretation, and hopefully one of the two makes sense. Okay. All right.
Can we use an example from one of the problems in one of the assignments?
Did you have one in mind, or are you just asking?
Let me see. I just barely looked at them this morning. Let me see if I have. I don't know. How about, let's see.
What page you on?
How about number, let's see, is it 69, page 137.
137. Number 69 says.
I haven't that, but
Oh, all right. So this. All right. So if we want to do this problem, great. It's not really what we're doing right now, but we can. It's sort of related to what we're doing right now. So let me throw this up on the. Let me share this real quick. So this is section, what is this? 3A, number 69. In 2015, alcohol use among high school seniors was down from the previous year by 5.6% to 35.3%. What was the usage rate for the previous year? I like it. Okay, now just read that through and think about it for a minute. Is this a case where you can just add 5.6 to 35.3 and get 40.9 and be done?
I don't think so.
No. What would they need to say if that was the case? They would need to say it's down by 5.6 percentage points. I really want, you remember when we talked about this? If
Was
I
this
go
like the
from,
how?
stay
was-
with me. If I go from 3% to 4%, I could say that's an increase of 1 percentage point. Or I can say it changed by 1. It started at 3. So it's 1 divided by 3. It's a 33.3% increase. Okay, let me stop for a minute. You guys remember that? There was the like absolute point change, and then there's a percentage change. And the point change is a little more honest. It's a little more above boards, right? Does this one say anything about percentage points? No. So this one, so just to make, let me see if I can make this a little bit easier. Let me stop sharing. So you guys should get the idea there. You put that back over here. Where'd you go? Donde está? There you are. Okay. So it started somewhere. So our starting point, we don't know. It changed. What did it say? decreased by 5.6%. And now it is 35.3%. Do you guys see how this is exactly like the problem we were doing yesterday, the problems, the algebra problems, where we don't know the original? I mean, what would you say this is? We don't know what the start was. So what is it?
X.
X. So I started at X and I decreased by 5.6% of what?
X.
Good. So what am I going to put right here? 5.6%. It's going to be written as
0.056.
Let me stop for a minute. So this really is just a 5.6% discount. It started somewhere and it went down by 5.6% of that. And then we end up where? We end up at 0.353. So now you just got to solve for X. This would have been so much easier of a problem if it would have said percentage points. Then I could have just, if it went down by 5.6 percentage points, I could just add that back onto this and be done with it, because that's what percentage points means. That's just purely, I'm just looking, it went from 20 to 30, that went up 10 percentage points, right? That's not a percentage of what it was. That's an easier problem. Okay. Do you guys see how this is exactly like a discount problem? It decreased by this. That's a discount problem. We did a bunch of those yesterday. The shirts and the hats and the laptops and the cards and whatever. Maybe? No? Okay. Yes. Okay. I got a yes. Yay. And then, whatever the shit that is. We did plenty of these. Hopefully you guys can still do this. 1 minus that. Divide, and you're done. Yeah.
Does that, does that answer the question? And also, how do you, I just wrote that out. Now, how do you figure it? How do you do that?
Well, all right. What's one of these minus 0.056 of these?
I don't know, because I don't know what X is.
No. What's 3x minus 2x? What's 3x minus 2x? X. How did you do that? You don't know what X is. Who gives a shit? I'm just saying how many X's are. So if I have one whole X minus 0.056X, you could even just put that in the calculator. 1 minus 0.056. You're going to get 0.944.
And how did you get the 1 by the X?
Oh, okay. What does that X mean? How many of those X's do I have? Do I have 18 of them?
1.
No, I have one of them, yeah.
Oh, okay, X. Oh, hello, yeah, I know that.
Yes.
Yes.
But again,
I need to sleep.
Again, no. As a math student, what's really difficult is all right, listen. What's difficult is to know what comes forward with you. The funny thing is everything you learn comes forward with you. Anything I write has a 1 in front of it. And if it has a 1 in front of it, it has a 1.00, as many O's as I want. So this is like 1.0000 minus 0.056. So then I get 0.944. Real quick, side note. What? 0.44? No. 0.056. Careful. Side note. Well, let's finish this out. Well, this is a homework question. I mean, what are you doing from there? You just divide, don't you? You just divide, right? Is that cool?
Yeah.
Cool. Well, let's go ahead and do it. What do you guys get when you divide by 0.944?
I got 0.37.
37?
How many decimal?
I don't know.
Do you
Just
divide?
tell me a few.
It's 3739406.
Okay, so 0.374. A good general rule is, do you see how this has 1, 2, 3 things? So your answer should have 1, 2, 3 things. That's So 37.4%.
What had 1, 2, 3, 4 things? What was that you just said?
Sorry. So this has 1, 2, 3, right?
Okay,
So your answer should have at least 1, 2, 3.
perfect.
I'm not going to force sig digs into every problem we do. Thank God. Right? I could, but we're not going to. So in general, you want the answer to have at least as much precision as the pieces did. Okay.
So does that answer, that's the answer to what was the usage rate for the previous year?
Yes.
Oh my gosh, how easy was that?
Because the previous year is what we changed. So once I solve for X, that is the previous year. So if they would have said it decreased by 2.1 percentage points, I would have just had to add 2.1 back on. Bam, done. So percentage points, that's what they mean. If they don't say percentage points, shit, I've got to do this crazy ass thing. Okay. What was the other point I wanted? Oh, now watch this. This is going to come up a few times. You probably are like, well, math boy, you should be able to do that in your head. But I did that in my head. But how do I do 1 minus any decimal? Watch this. This is cool. I know you have a calculator. I know you do. Watch this. This is cool. What makes that 9? 9. What makes that 9? 4. What makes the last one 10? 4. Done. So if I had 1 minus 0.12845, what makes that 9? What makes that 9? What makes that 9? What makes that 9? What makes that 10? Done. Why does that make sense? 5 and 5 is 10. Carry the 1. That was 9. Now it's 10. Carry the 1. Now it's so you get 1.00001.
Is that how you did it from that direction? You started from right to left?
Yes, a shortcut. It's a shortcut. If I make this 9, 9, 9, 9, 10, carry the 1, carry the 1, carry the 1, carry the 1, and now it becomes 1.00000.
And how did you do the top one?
What do you mean? Oh,
The
same.
0, yes.
Make this 9, 9. Make this 9, 4. Make this 10, 4.
Oh, yeah, okay.
Yeah, so it's just a little thing about numbers, right? I know you have a calculator. I love it when a student's like, they invented these things called calculators, right? Mr. Wallace, shut up, be quiet. We're humans. We're better than calculators, I hope. Okay.
Professor, I have a
Yes.
question. I guess it's a bit off topic, but it's about relative errors.
Sure.
Do they use that to determine whether or not the method they're using to get
Yes.
whatever information is accurate or not?
Yes, there's several. I love it. Thank you. They could use it to verify that a new method of measurement is accurate. So if they have something they know, and then they use a different different way to measure things, it's got to come out with the same value. So they can kind of measure methods to, well, let's see, they can rank measurement methods by their relative error. But it could also be used to see if there are other things happening, right? So if I do an experiment and I predict that the measurement should be off because of this other thing happening, and I get exactly what the amount of error I predicted, then that's, I don't know, does that make any sense? So what you said is good. If you come up with a new way to measure something, and you can kind of test it to see how good it is based on what we know. Sort of like if you buy a new scale, don't you put like a 5-pound weight on it just to see, does it say 5 pounds? If it says 10 pounds, screw that scale. Get out of your scale, right? Or I need to re-zero it. Are you guys with me at all? Re-zero, that's a really good anime. All right, let me clear this. So thank you. That was a really good point. That is one major use of that, but there's a lot of other uses for relative error. There really are. Okay, anything else before we leave chapter 3 and shoot way ahead to chapter 12? Okay, all right. Let's see. Go away. Let's see. So chapter 12 is about the exciting world of how to freaking vote for anything, right? Let me see. Before we do this, let me see. Here we go. Yeah, let's do a little bit. We'll do a little bit of 12 and then we'll take a break. I was going to take a break first, but let's just do a little bit of 12, get some of that under our belt. So first thing I want to ask you is this. We just had, what just happened earlier this month on January 5th, to be precise, not the 6th. Bad things happened on the 6th. What happened on the 5th that was important for our government? Anybody know? Has to do with my home state of Georgia.
It was the elections.
Yeah, exactly what kind of elections?
The runoff.
Runoff elections. What does that mean? Does that mean they were voting on what to do with runoff from waste plants? No. What is you guys are like? Sorry. What does runoff election mean? Does anyone know?
I think it's in the initial election, no one candidate won more than 50%. So the leading ones win again. To try to
Good.
get 50%.
So, yes. So they take the top 2 vote getters and then they have an election again. So voters then come vote again. Are you with everybody with me so far? So that's what happened, right? And then however you feel about the outcome, nobody gives a shit. It's just that's what happened. All right, I like it, right? I personally enjoyed the outcome, but that's enough of that. It's my home state too, so Georgia coming through. That's called a runoff election where they redo an election, taking the top 2 vote getters. Not many places do that, but there are quite a few places that do. Why does that make sense to do a runoff election? So like was just said, you don't do a runoff election unless no candidate gets more than 50% of the vote. So what is it trying to guard against? This is getting interesting. I don't know. How much do you guys pay attention to politics? So for example, let's go way back in history, ancient times. Anybody know the name Ross Perot? No? Big ears? Let me tell you something. It's going to be a big sucker sound. No? All right. Let me say something. All right. I'm sorry. I used to do Ross Perot all the time. Or even Ralph Nader. How about Ralph Nader? Anybody know Ralph Nader? Poor Ralph Nader. He used to be something. So let's imagine we have an election, and let's say there's only 3 people running. There's a Democrat, there's a Republican, and then there's somebody from the Green Party. Have you guys heard of the Green Party? Do you guys know the platform of the Green Party aligns better with which political party? Do you know?
The Democrats?
The
Isn't environmentalism their whole thing?
Yes. So you can argue that in the system we have, you can have what's called the spoiler effect, right? Has anyone ever heard of the spoiler effect? So for example, there was actually in this last election for president, there was a libertarian person who ran. Stay with me now, stay with me. I know. This is not going to become a political science course all of a sudden, but just a little bit it will. There was a libertarian who ran. Libertarian values line up better with conservative values. The person that ran in libertarian got more votes than the difference between Biden and Trump. So there were some people saying if that person had not run, Trump would have won those states. Now, that's basically been debunked because not every libertarian would go for Donald Trump because some people understand it is sometimes about the person, right? But somebody sort of, so this idea of a spoiler effect is one of the main problems with what's called plurality voting, right? Majority wins. So that's basically what we have. Now we have plurality voting coupled with a weird ass electoral college, right? Oh, I feel bad if you don't know much about this. Does anyone know much about the Electoral College? Yes, and it does have historical purpose for existing, but that purpose is mostly historical, right? And that purpose is actually entrenched in some pretty bad history, to be honest. There we go. We got some people. And I'm not, now listen. I am not trying to force opinions down your throat. You can investigate this all you want to. Just understand that research doesn't mean find somebody who says what you like and stick with it. I really won't. That's not what research means, which a lot of people think. I found like 8 YouTube websites that said what I like. I did lots of research. No. And I can use that accent because I'm a redneck. I'm a non-practicing redneck. Born in Georgia. Now, oh boy, I'm getting myself in a lot of trouble. I'm almost certain. I'm waiting for somebody to turn me in. That commie socialist teacher. God damn it. All right. Where was I forgot. Electoral College. So what we're going to talk about, I think we're going to take a break so I can kind of reset and refocus. Right. This is always where I go, especially with recent events. I have a very difficult time staying on track when we're talking about politics. Well, when we come back, we're going to get a little more focused. We're going to talk about our system, and then we're going to talk about possible other systems that we could use. I have a couple of YouTube clips I might show you. I've got to remember to turn off my recording, or else YouTube will tell me that I've copyright laws and all kind of shit. Yeah, so let's go ahead and take a break. We're going to transition into 12. We're going to get deeper into the specifics and have less opinion shit. So I'm sorry if you don't agree with me. So I'm going to do less of that as much as I can. Oh, okay. Yeah. Electoral college is an interesting debate to have. So let's take a break. Let's see, what time is it? So come back, let's say come back at 10:30. We'll do as much out of 12 as we can, and then we'll call it a day again. Okay. Everybody.
Hello, I'm here.
Hey, Ian. All right. First thing somebody just brought up, I want to remind you guys where this is. So today I've got the extra office hours. So I'm I think each week we will figure out the best days for these kind of extra office hours. So I had them on Monday, and I'm going to have them today, 3:30 to 4:30. So it's right after tutoring ends in the Math Study Center, up until 4:30. Okay, I like it. So you can bring questions about homework or whatever. Okay. Also questions from the quiz too, if you want to talk about that then. That's good. So that link will be there. So be very careful. This link only works for this purpose. If you want to come to class, you of course have to use the link that's right here in the announcements. This one will work for the whole semester, right? The whole semester, yeah.
The one that I could not find this morning.
Yes.
That's why I told you I took the long route. I took the long route. It was like, which route do I take?
I didn't get your message until
I was good, but I found it. Yeah.
Okay, so let's get back into this. Oh, let's see. Right now, I was kind of in the break. I'm watching. Do you guys know what's happening today, politically or government-wise? Anybody?
Are they moving to impeach Trump?
Yes. So the House is considering impeaching Trump for a second time. Yeah, and that would be the first time that's ever happened. I'll stop there. I won't get into my opinions. I think everybody could probably guess what my opinion is. Anyway, sorry. So I want to talk a little bit. So we've already talked about 2 of the 5 voting methods we're sort of going to focus on. There are many more than 5. But a lot of the other ones are variations on these 5. And actually one of the 5 is a variation on one of the ones we talked about. Holy shit. So we have what's called majority vote. So we've actually kind of talked about 3, to be honest. We have a majority vote. When would a majority vote work best? If what was true about an election, if I had how many candidates running or how many options, when would a majority work best? Yeah, I mean, if I only have 2 candidates, and a lot of people sometimes think there's only 2 candidates for president. I think I already said this. Do you guys know how many candidates for president there were actually?
I think you said 100 or something, right?
No. That was for California governor, I think, way back when like Gary Coleman ran for California governor. Do you guys know how many people ran for the presidency? It was above 1,000. Right? I could take a minute and find. You can search for the complete list. It's insane. Anyway. If we truly only had 2 options, majority rule is simple and best. It's when we have more than 2 options that things get really murky. Right? And that's the whole spoiler effect we talked about. Okay, so what have we talked about so far? Let me write some stuff up here. All right. All right, get over there. That's neat. Wow. All right. We have majority. Get out of there. Majority rule. All right. And this just means the one, the one getting greater than 50% wins. Right. The person, the item, the whatever it is. So, for example, when we vote on propositions, there's only 2 options: yes or no. You could say, well, I could just not fill in a bubble. Well, then you just chose not to participate. That's not a third option. That's actually, so then majority rule makes complete sense, right? For propositions. Most of the time, you gotta be able to. All right, let's just do this. Secondly, we have the idea of a plurality, which means if I have more than 2 people, more than 2 choices, the one with the most votes wins. So majority specifically means greater than 50%. Plurality means you could win even if you get 11%. Do you guys understand? If I have 10 people running for office in something and one person gets 11 and everybody else gets 10 or 9%, then the 11% wins. Democracy. All right. Now, then we talked about this. We talked about runoff, right? What runoff tries to do is it tries to improve on plurality. It says, all right, you kind of do this, and then the top 2 run against each other. And in which case, this becomes the thing. Do you guys understand what's happening so far? So plurality, you could have 1,000 people or 1,000 things. The top 2 from that then go and face off in another election. Top 2 face off in another election. All right, get out of there. Okay. How are we doing so far? This is not too crazy. So majority works best when there's only two. Plurality is what we sort of do in our presidential election. Of course, it's got extra little shit in there. And then runoff is trying to improve on this bad boy, because this bad boy comes with a possibility of spoiler effect, right? You see, I got some more colors here. So this could have oh no, green. Can you see green?
Sort
yeah,
of.
sort of. Spoiler effect. Oh well, you're brand new too. You suck. All right, let me try this again. How about blue? That's psychedelic. I like that. All right. Spoiler effect, right? That's what could happen with plurality. Okay, nothing too crazy so far. Now let's talk specifically about our system. The book says our system is a majority system, but it's not really true. I think we all kind of know this. The reason is that, especially for president. Now, stay with me. I know.
Excuse me, Professor. I'm
Yes.
so sorry.
Sure.
What is that word there? What is that word on the board behind you?
There's so
It
many.
says number 3. It says top what?
Top two.
Okay, top. Okay, runoff. Top.
Top two face off
Okay.
in another election. Yeah.
Okay. Okay. Thank you.
And then it makes it really easy, right? So you understand the appeal of runoff. In fact, that would be a great immediate thing we could do. What's the problem with a runoff? What's the problem with it? Does anyone know?
Time and money.
There you go. Time and money, right? Especially the money. Every time you have an election, it's going to cost money. So there is another option we'll talk about in a minute that kind of does this, but in a better way. All right. With no other election happening. Do you guys know? All right. When I ask you, how many total electoral votes are there? Let me see, where are you?
I was gonna say 237, but I just saw 273 on the textbook.
No. How many total electoral votes are there? Now, let me find this page first. Does anyone know? No?
In
How
chat,
many? Sorry?
in the chat.
Oh, I'm sorry. 536 is close.
Oh no, it was 270 to win, wasn't it?
270 to win. There you go. And there's a website called 270 to win. 538. There's another website called 538, which actually does a lot of statistical analysis about all kinds of things, not just politics. Talks about sports and there you go. I don't know. Those are sports and politics and other things. I gotta find this. Do you guys know? All right, let me show you a couple things. Okay. This is interesting about what order to show you all this stuff in. So one reason why our election is not truly a majority is because, for example, if we just look at Arizona, Biden got all the electoral votes, but did he get a majority of the popular vote in Arizona?
No.
No, he didn't. He got 49.4%, right? You guys kind of with me so far. So that's obviously, to get the electoral votes of a state, that would be a plurality. To become president, you have to win a majority of electoral votes. All right. I'm boring the shit out of myself. I'm sorry. Stay with me. Stay with me. So the other thing, of course, I want to do this in the right order here. Electoral votes, there's 538 electoral votes. So what's half of that? That's 269. That's why they say you need 270 to win, because then you would get more than half of the votes. So could a tie happen?
Yes.
Yes, a tie can happen. They could both get 269 And then, of course, the vice president, I believe, if I remember correctly, would be, is it the vice president or is the, oh shit, I used to know this because this was a possibility for this past election. I can't remember now. Who votes? I think it's the vice president. Votes on, it's not the vice president. That doesn't make sense. Screw it. I can't remember. So somebody, I think it might be the Speaker of the House. I can't remember. Somebody has to then decide who cast that break the tie vote. A lot of other weird shit could happen. I think it's enough of that with our system. What else did I want to say? You could do it, Jeff. Yeah, I think that's enough right there.
Professor, so the
Yeah.
electoral votes are 538.
There's a total of 538.
Okay.
So the candidate that gets to 270
Okay.
win,
Okay.
because then they would win over half of the electoral votes.
Great. Thanks.
Unfortunately, that means that the candidate who gets the least number of popular votes just from the whole United States might win. And of course, that happened before 2000. That happened twice in the entire history of the US. After 2000, it happened several times. And not always just Republicans, right? So there hasn't been a Republican that's won the presidency since 2000 that won the popular vote, I think, except for 2004. In 2004, there's a guy called John Kerry, right? John Kerry has a very long face. Hello. But John Kerry, if he would have won a few more votes in a couple of states, he would have won the presidency, but would have lost the popular vote, right? And you all know that, for example, Trump lost the popular vote in 2016, but he became president because of the electoral vote, right? All right, now. Here's the other piece I want to talk about. The last thing I'll say about our process and the Electoral College, if I can find this page. You could do it, Jeff. Can you do it? I don't know. So Donald Trump in 2016 won 306 electoral votes in the election. But he didn't end up with here it is. Thank God. He didn't end up with 306. Now look. So California, for example, California has 55 electoral votes. So the candidate who wins California gets 55 electoral votes. Does every state work that way? Do you guys know? Does every state give all the electoral votes to the person that wins the popular?
Some of them are proportional, aren't they?
That's right. Nebraska and Maine divvy up their electoral votes based on the percentage of the popular vote, right? So that actually sounds a little bit more fair. You could lose a state by one vote, and then the other guy gets 55 votes and you get nothing. You get a big fat nothing, right? So some states, the Constitution doesn't say you have to give all your votes. Okay, I'm trying not to make this into a political science history class, but all right. Look here. See this? If you add these up, it doesn't make 538. Right? It makes 531. Does anyone know what happened with 7? The answer, I think, is on the page there almost. With those 7 people, and electoral votes are people. We vote electors. And if you paid any attention at all to the things that have happened in the last several months, you've learned a lot about government. Holy shit. So a state, somebody wins a state, the legislature sends people, electors. So California sent 55 electors to the Senate for them to count. What happened in 2016 that I think has only happened twice before? I can't remember. 2 of the people that were sent to vote for Trump didn't. They're called faithless electors. So this is something people were really worried about in this last election, although it was just way too big of a margin to worry about, and nothing like that happened. So 2 people that were sent to vote for Trump decided on their own to cast their votes for somebody else. 5 people that were sent to vote for Clinton did the same. They decided on their own not to. Does that bother anybody? Independent of who you wanted to win, right? So a state picks a person, but then those votes, depending on the people we send, they could decide to give it to somebody else. There are actually rules. I forget now how many states have laws against faithless electors, but not every state does. So in some states, they have an elector, they send him up and the elector goes, you know something? I like the other person. Yeah. And all of a sudden that electoral vote goes to them. So our system is insane, right? Okay. All right. So look here. This is the percentage of the popular vote that each candidate got, right? So Clinton got 48.25, Trump got 46.16. This is the percentage of all the votes in the whole country. And of course, here's the percentage in the Electoral College of the votes they ended up with. So you can see that's the thing that matters. The electoral votes you get is what matters. The popular vote, the way it's set up, doesn't overall matter. Okay, is everybody with me? All right, so this time, somebody had to win by 8 million votes just to make sure they actually could become president. All right. Enough of that. So we got so far, we've got majority rule, very simple. We have plurality, which is actually pretty simple. It's just the one who gets the most wins. We got runoff, which sort of tries to improve on this. But the problem with runoff is if you don't have enough money, you can't do that shit, right? You can't run another election if you ain't got the money to do it. It takes a lot of money to run an election. It's crazy. So we're going to talk about 2 more types of voting. Before I get there, nah, I'm not going to talk about that. I'll let you guys run up against that and see what you think. Yeah, there's actually 3 more. That's interesting. I thought there was total of 5. All right, if I could just count, my job would be so much easier. The immediate improvement we could try to make to runoff is to do what's called instant runoff, or I think the book calls it sequential runoff. So what this would require is for and actually, let me show you this visual. This would require allowing people to choose more than one person. So let me find this. You could do it, Jeff. Get over there. All right, let me share this. Pop. So here is a preference schedule. This is kind of like the thing that builds up for these next voting methods. So in a preference, can you guys see this here? So you don't just fill in a circle next to one person. You actually rank them is one way to do this. So I see Kim is good, and then Smith, and then Garcia sucks, right? It's basically what that's saying. Yeah, and then they kind of go through, like if they actually ran an election, there were 1,000 voters, and then this might be kind of like the way this shake out. So they actually kind of collect this together on the next page, I think. Maybe the next page. Okay. Yeah, here we go. Okay. Now. Let's just make sure we understand it. This is page 664 in the book. There were 320 ballots where this was the ordering. Is everybody with me? And then there were 330 ballots where this was the ordering and so forth. Who got the most first place votes?
Chrissy?
Well, so how many is this? Yeah. I want everybody to be with you on that. This is a total of
350.
350. Good. So if I was just doing the one who got the most wins, Garcia would win because they got 350 first place votes, right? Okay, I like it. Maybe. Now, if I were to do this sequential runoff, let me see if we can do this. You ready? Who got the least first place votes?
Smith.
Smith. So if I do sequential runoff, what this means is, since everybody's ranked their choices, I don't need a second election. I already know how they feel. So if I just eliminate Smith, let me see if I can write on this. Oh, I have to change hold on. Let me change over here. So much technology. Oh my God. I miss the old days. Okay, hold on. Get over there, and then I have to do this, and then I can write. Yay. Okay. So let's not kill Smith. Let's just cross Smith off. I was going to say let's kill Smith, but no. Now, what happens is between Kim and Garcia, do you see how Kim's got 650? Just imagining Smith's not there. And Garcia still has 350. So then Kim would win in a sequential runoff situation. Do you guys see that? So it captures the same idea as a runoff. It just doesn't have a whole other election because we already caught everybody's like second choice and so forth, right? Okay, maybe. That's not too bad, right? That's not too bad. It's basically runoff just all at once. We just get more information from people. Okay, I like it. Hey, Mikey. The thing is, let's look at this other way. Get out of here. Clear this. Go away. So that is sequential runoff. If there's still no candidate with a majority, the process is repeated until someone claims a majority. So that's kind of like if I had 10 candidates. We might have to do what we just did several times. Okay, maybe. Actually, let's go through this again. I didn't even look at this as a majority thing. Let's be more careful. So again, Jeff, don't say kill Smith. We're not going to kill Smith. So Garcia, stay with me now. Garcia has 350 votes, right? I think this is fine. I think we don't have to do anything freaky. I just want to make sure. Oh, Jeff, you have to plug this in.
Bluetooth connected.
Thank you, little voice. All right, let's see.
Have we not been recording?
Oh, shit. Have we not been recording?
We're recording.
Oh,
No, we're
okay.
recording.
Right.
You gods. All right. No, did you hear the dude's voice, though? Is that what it is? I never know. Anyway, all right. So let's do this. Now, Garcia, after the first runoff, has got 350, and Kim has got 650. So obviously, yeah, I don't have to do anything else. This would be 65% for Kim and 35% for Garcia. So I wouldn't have to keep going because Kim has got the majority of the votes. What would suck here is what if it ties after I eliminate one person? Well, then we're screwed. Then it's got to be something about what to do. Huh?
Professor, I'm sorry. How did Kim get 650? I have a hard time with this chart.
Now watch. Let me do this again. I understand. This is really weird, especially because we don't do this like this normally. We're all in agreement that Smith got the least first place votes, right? Kim got 330 first place votes. Garcia got 350 first place votes. Smith got only 320.
Yes.
Okay, good. So we're going to eliminate Smith. Pretend like Smith never ran. Now I got Kim has got 650. Do you see that?
Yes. Mhm.
Garcia has still got the 350. So Kim definitely would win.
Okay, got it.
Is that, yeah, okay, I like it. So
Yeah,
it is
thank you.
just that. Think about it. How does a runoff, just the normal runoff with a new election, we take all the other people out that got the least votes, right? This is basically the same, except we take one person, the absolute least votes, we take them out of consideration. I might have to do this several times if we don't get to a situation where somebody has more than 50% of the votes. But since there's only 3 people on this one, I only had to do it once. All right, maybe. So again, just to remind you guys about how weird this class is. I'm almost certain, and again, today is a beautiful example of this. It sort of became a government class. It sort of became a history class. And then, of course, it sort of became a Jeff gets to rant class for a little bit. I try to keep that down to a minimum, right? But there's still an underlying thing about the math. This is the math coming into all of this. And the really interesting thing is, we're eventually going to see mathematically, we've proven that there is no voting method that we currently know of that meets what we're going to list later, that the fairness criterion. No voting method meets all of the fairness things at once. That's kind of frustrating, but what we do know is the way we currently do it is basically the worst way to do it. So, all right. I just lost somebody. I understand. The next way to do this is with the point system. And this is basically, this isn't too crazy, right? We assign points and a little, all right. So for example, we would give 3 points for first place, 2 points for second place, and 1 point for third place. You guys with me? Now this is definitely leaking directly into math now. We are totally in math. So let's just do one of these people. Can we figure out how many points Smith got? I really want you guys to be with me on this. The math here is not difficult. It's just that it's on top of all this weird voting shit. So if we say first place is 3 points, second place is 2 points, and third place is 1 point, why would this not just be 3 points? Because how many times did this happen? 3 and 20. So what's Smith's points? Take a minute and try to figure out what Smith's total points would be. So for this first column, it would be 3 times 320. So 960 plus, go to the second column. Keep going. If you're not sure what the shit is happening, just hang out for a minute. But I really hope you guys see what's happening. Oh, man. So here's some more math. This is kind of funny. I think we talked about this before about when the math comes in this class, you're kind of like, oh, good math. Yay. Oh, man. So let me catch up with you guys a little bit. The second column, Smith is in the second place. That she'll get, I'm assuming it's a she because I know somebody with the last name is Smith. 2 times 330 is 660. Is that cool? So she got 2 points for every second choice. And there were 330 of those. And of course here, she's in second place again. So she's going to get 2 times 175, which is 350. And then here she's in last place. So she gets 1 point for every one of those votes. So she gets 175. Does anyone not understand where those numbers came from? It's okay if the answer is no. It's just not okay if you don't tell me now.
I'm starting to get it.
All
It
right.
just helps when I read it and when I read in advance.
Sure.
Didn't read in advance.
Oh shit. So what, can somebody help me out? What do you get when you add all these together? 185, 2145. Is that what that is?
So are all of these Smith's points for in total or just a second?
So you ready? So first place votes gets 3 points.
Yes.
Right. So in this first column, she got 320
Yeah.
first place votes. So that's 320 times 3 is 960. And then she got 330 second place votes. So that's 660. Oh, I have a chat coming at me. Oh, good. So it is 2145. Thank you. Holy crap and a half. Wait a minute. Sorry, my pen is going crazy. All right, now let's keep going. Why not? Let's have so much fun. Oh, Jeff, how much fun can one class have? Can you do the same thing now for Kim? Okay, pen, what are you doing?
Oh, so you just go across and you go across the columns and you choose whatever names. For example, Kim has, in the first row, she got the second choice.
Place.
And so
320.
that means she gets those 2 points. And then in the second row, Kim got first choice. In the second row, she gets
3 times
3
330.
points. So that's 3 times 330.
990. I like
30,
it.
yes. And then Kim gets third choice in the third row. And that's 1 point. So that's 1 times, well, that's 175. Is that it?
Yeah, you got it.
Then Kim,
And then,
okay.
and then
I
last
see.
column, second place. So you get 2 points for each of these. 350. And so I think somebody added it up. 2155. Is that what you said?
Oh, wait a minute.
Huh?
Who
Sorry.
gets 3 points for, you get 1 point for 175 or for third choice, don't you?
Yep, that's happening right here.
Yeah.
And then here she got second place, 2 points times 175.
170. There we go. Okay.
Yeah.
Can you just I want to jot that down.
Yeah, go ahead. Now, guess
Is there any
what,
way you
kid?
can post that?
The funny thing is they do all the work on the next page. I don't know.
Oh, okay.
I'm just trying to do it now. So when we see it, it's like, yeah,
Sure.
we just did that.
Okay.
And now everybody's going to look on the next page, but oh, well, too bad. I mean, you do the same thing for Garcia, right? Same idea for Garcia. Garcia is going to come out very bad because where there were more voters, Garcia did worse, right? So they're not going to get as many points. Oh, somebody's calling me. Okay. Is everybody with me? Has everybody got that copy down? I'll go ahead and go to the next page so you can see, what Garcia comes out to be. You can calculate it yourself too. Has everybody got that written down? I'm going to clear it. Here it goes. Bye. Okay. So I believe it's the next page. They do all the work. Yeah, here we go. See this? Don't those look familiar?
Yes.
Yeah. Isn't it much more satisfying to say we did the work and they were like, oh, good, book. Good job, book. So in this case, Kim would win. Now look up here. We did the sequential runoff thing and Kim won that. Remember that? Kim won the sequential runoff. Okay. So we've got sequential runoff, which is where the lowest person, you kick them out and then you reevaluate. Does that make sense? That's the shortcut way to define sequential runoff, is the least votes gets eliminated and then you reevaluate who's left as if the other person never existed. The point system, you can give 3 points, 2 points, 1 points. The little point over here is, you can actually do this so many different ways. You can give 10 points, 5 points, 1 point. It just depends. The official way is to start at the lowest place gets 1 point, and then you increase by 1 point each place you go up. So, I mean, you could have 10 candidates. So the 10th place gets 1 point, the 9th place gets 2 points, and the 8th place gets 3 points, and blah, blah, blah. Okay. All right. Maybe. And then we got this freaky ass way to do things. So the pairwise comparison. Oh, I didn't even write anything down for them. All right, so let's see what this means. Don't look at the next page. Let's just try this out. Each candidate is pitted one-on-one against each other candidate. The winner is the candidate who wins the most one-on-one contests. So how would we look at that here? All right, let's look at Smith and Kim first. You ready? Stay with me now, everybody. We sort of wandered a little bit away from what you think about as math, but too bad. So Smith and Kim. So this one, Smith wins. Do you see that? So if we look at each one, Smith wins the 320 times. Then Kim wins. Let me do this a little bit better. I really want you guys to understand what I'm saying. I just have to write it better. No, Jeff, come on, you can do it, buddy. There you go. Let me do this again. All right, let me say what I just said again. So look at Smith. Smith wins, when only compared to Kim, Smith wins 320 times. And then here she wins again, right? If you look at each one and you pretend like only Smith and Kim exist, Smith beats Kim 175 times. What about Kim versus Smith? Kim wins here 330 times, and Kim wins here 175 times. So far, yeah, see how Kim's 10 more? I don't know. Are you guys with me out there? So that's 495, and this is 505, right? So between Kim and Smith, Kim wins more, right? So far. Then you have to compare Smith and Garcia the same way, and then you have to compare Kim and Garcia the same way. Can you imagine how disgusting that would get if you have like 10 candidates? Thankfully, you can program a computer to do that very quickly, unless you think it was like Hugo Chavez programmed it himself or something. If you don't get that reference, it's okay. You probably feel better than I do. So let me see. Let's see how that comes out. So if we do it with pairwise comparisons, do you see how this first thing is what we just did? You guys see that? Smith versus Kim, the most boring movie ever made. Smith versus Kim. So 495, 505. And then you do the same thing with Smith and Garcia. So Kim won against Smith. Smith wins against Garcia, but Kim wins against Garcia. So Kim won twice. So Kim would win the whole thing.
So that's pairwise. That's what you just did right now on the board, right?
That's right. That's pairwise.
Okay.
And again, the more candidates you have, the more pairs possible, right? Which kind of makes sense. So once you get up to like 6 or 7 candidates, this is kind of insane, the number of you got to do. But again, a computer would just eat that up. All right, now I am not going to make you memorize all the intricacies of these systems. You do, now listen, the names of these should tell you how they work. But if I give you a problem on a test, I will give you a table like this. And I would give you like a few and I'd say, do it this way, where you give 1 point for this and 2 points for that. Bam, right? I'm not going to make you memorize all the little steps for each. I will give you a little bit, but you if I say sequential runoff, you should know basically what that means, right? Maybe you get this. All right, so I am going to give you a little bit of help, but I'm not going to tell you exactly how to do everything. I'm not sure how else to say that. Okay. So let's talk about this. Now that we've talked about several methods, let me do this. Let's do this. I'm going to stop sharing. I'm going to stop recording.
So math teacher.
Sorry.
Mars, little people.
Oh yeah, little blob people.
So, yeah.
That's right. They're both the same video, just from different perspectives. So the idea of approval voting. Let me show you. I think the book's got a couple of visuals. Where are you at, book? Here you are. And now I've lost my class. There you are. So approval voting is nice because it's not ranking anybody. Let me see, where did approval voting go? The book is really good in this section about tons of examples and talking through all the steps and talking about the weird things that could happen. Oh shit, is approval in the second? Approval might be in the second. Oh yeah, it is in 12B. Okay, that's good. Get in here. Come on. There we go. Oh, okay. I'll come back to that in a minute. Let's talk about approval. Where are you? Oh, it sucks so much. I forget where. There you are. Okay, finally. So there's no ranking. It's just you can mark you approve. Now I think the idea would be there wouldn't be any disapproval. You would just leave it blank, which means you disapprove. But you could actually have it where you explicitly say, I don't like this person, right? So they do a real quick little example here. So we have a Mr. A, Mrs. B, and C, right? They them do an election, and they go through what happens. 32% want A as the first choice, but would be cool with B, right? So in a sense, this is a little bit of how do I want to say this? This example kind of improves on the basic idea by letting them rank their choices, which is interesting. 32% want B, but would approve of A. 1% want A and don't like B or C. And 35% want C and don't like A or B. So all you do then is you add up how many are A approved by, right? So I don't know why they have the first choice thing. That's kind of silly. So 32% here like A, 32 more percent like A here. Is that cool? Do you guys see that? So 32 plus 32, 1% like A plus 1%, so 65%. And then you do the same thing. B, 32% like B here, another 32% like B here, and then nobody else likes B. And then C, only 35% like C because nowhere else where they approve. Can you guys get that idea?
Yes.
So this does seem to be an improvement, but again, this would make the ballots a little more possibly complicated, and then the counting of the ballots gets a little more complicated. And you can see how bad of a time we have understanding simple ballots at the moment. So that's approval voting. That's what approval voting looks like. Approval voting does have a drawback. They do talk about that here. I do want to go back just for a minute, and then we're going to call it a day, I think, because I am not feeling great. Here is where they talk about these 4 things that voting theorists agree on would make something fair. And obviously, criterion 1 would be if there's only 2 people running, is when criterion 1 really makes sense. But even if there are 3 people running, if 10 people run and one person gets 51% of the vote, wouldn't you agree that no matter what you do, that person should win? What do you guys think? You could probably come up with something that would go against that, but it makes sense that if somebody receives more than 50% of the vote, then any voting method you use, that person should end up winning. Okay. And you can read through the rest of them. Yeah, I'm really going south. I don't know what's going on. So I think that's enough for today. So hopefully, so I'm going to take some more meds. We'll see if later I feel better. I should be there. I don't see why I shouldn't be there later today. Let me know if you have any questions right now. Otherwise, that's enough for today.
So I do. When is this assignment due?
Oh, I made it. If you go in Canvas, it tells you. There's never any.
It's in the new. You didn't change that, right? In the new syllabus.
Syllabus doesn't say anything about due dates. Syllabus
Okay.
says nothing about due dates. So if you look in Canvas, all the
Okay,
syllabus says
sure.
when we'll be talking. So right here, like
yeah.
section 3A,
I can check it.
midnight tomorrow. That's when that's due.
3A, midnight tomorrow.
And then 3B, 3C, the same thing. And I'll try to throw 12 in there.
So chapter 3 and then chapter 12. Chapter 3 is due by midnight tomorrow. Chapter 3, and then now the one on politics. Chapter 12.
Yeah. So again, I haven't put that into Canvas yet.
Got it.
But you know it's going to be due.
Yeah. Oh yeah.
Let's see.
Yeah.
No. I don't mean just do. We don't have see how we don't have a quiz on chapter 12? Because instead we're going to have a midterm on including chapter 12. So chapter 12 homework is definitely going to be due by the 19th. Right? There's a method to my madness. Do you understand? So as soon as I get chapter 12 constructed in Canvas, it'll say January 19th as the due date, because that's the day that you'll be tested on it. All right. How's everybody else? Anybody else? Any questions? You guys, if you have no questions, you could head out.
See you later. Feel better.
All right. Thank you.
Do what I can.
Yeah. Take something.
I will.
There are a lot of different, nice remedies out there.
I know.
Better.
Thanks for the lesson.
Put it in your mystery drink. And we'll see you at 3:30. You'll be feeling vibrant.
I might
Thank
need
you.
lessons.
Bye-bye.
Okay. Bye, guys.